Hi everybody, Mr. Orme back again to have a little think about some maths, and today we're going to think about equivalent fractions. Now, before we get started, we're just going to have a look at my little fraction wall. So this has got lots of different fractions on, so our whole, every time it's a whole, and it's been split into equal pieces, so we've got halves, thirds, quarters, fifths, sixths, eighths, tenths and twelfths. Now, we are looking for equivalent fractions, so fractions that represent the same amount, because equivalent, this word, means the same as, equal to or the same as something else. So we're looking for equivalent fractions, fractions that represent the same amount. So just by looking at my fraction wall, we can see that a half is the same as 2 quarters, and that's the same as 3 sixths. And that's the same as 4 eighths, beg your pardon, because there's 1, 2, 3, 4. It's the same as 5 of the tenths, and it's the same as 6 twelfths. So just from looking at my fraction wall, I can say that 1 half, 2 quarters, 3 sixths, 4 eighths, 5 tenths, and 6 twelfths, they all represent the same amount. So if you were sharing sweets or sharing pizzas or sharing anything, and someone said, "Can I have 3 sixths of your sweets?" and someone else asked for 5 tenths of the sweets, then you know that you would simply be getting half each, because they are equivalent to a half. Now, we're going to have a look at how we can find lots of different equivalent fractions for the same fraction. Just like we've done there, but without using our fraction wall as much and thinking about some of the maths that we can use to help us. Now, when I'm looking for an equivalent fraction, I might start with 2 sixths. Now, I've got 2 sixths there, and I think to myself, right, what can I use to help me? Now, the first thing we can do is we can think about multiples. Now, a multiple is simply a number in a times table. So if I want multiples of 6, I'm thinking about every time we multiply 6, those different numbers we get in the 6 times table. So if I multiply 6 times 2, I would get 12. So 12 is a multiple of 6. Or if I multiplied it by 3, I would get 18. So 18 is a multiple. And if we carry on multiplying by 4, I would have 24, 30, 36, and so on forever. Now, that's one way to do it. So using my multiples, I could look at my fraction that I've started with, 2 sixths, and I could say to myself, right, I'm going to use my multiples. Right, I'm going to make this into twelfths. So I want to change from sixths to twelfths. Now, to get from my sixths to my twelfths, what have I done to the 6, the denominator? That's right, I've multiplied it by 2, haven't I? I've multiplied it by 2, I've doubled it. Now, whenever we're thinking about equivalent fractions, whatever we do to the denominator, we must do to the numerator. We must treat both of them equally and do the same thing, so that equal word comes back again, equivalent. We're doing the same. So if I've doubled my denominator to get from 6 to 12, I also need to double my numerator. So if I double 2, my new numerator would be 4. So 2 sixths is the same as 4 twelfths. And if I bring my fraction wall back very quickly, we can actually look at this one. So there are my 2 sixths. There's one of them, and there's the other one. And if we follow down my fraction wall, you can see that it lines up perfectly there with 1, 2, 3, 4 of the twelfths. So 2 sixths and 4 twelfths represents the same amount. So that's one way of using multiples. And then I could continue forever. So I could either go back to my sixths and say, right, I'll go back to my sixths, and I will this time think about a different multiple of 6. What about if I made them into 24ths? So this time I've taken my 6 and I've multiplied by 4. I'm using this multiple. I'm timesing by 4. So I've times by 4 to get from 6 to 24. So if I've done that to the numerator, I must do it to the, beg your pardon, if I've done it to the denominator, I must do it to the numerator. So 2 multiplied by 4 would give me 8. So 8/24 is an equivalent fraction of 2/6. They are equivalent, they are equal to each other. Now, if I was to have a look at this in a different way, there's another way we can look at it. We can use multiples to multiply the numerator and the denominator, and that will work for absolutely any fraction. But there is another way we can do it. Sometimes you'll be asked to give an equivalent fraction for something like 10/12. Now, 10/12 is already becoming a slightly more complex fraction than perhaps we need to work with. You know, when we think about fractions in year 5, we sometimes solve problems, and that might be a slightly tricky fraction to work with. So we could also think about using factors to find an equivalent. Now, a factor is a number that you can take your 12 and you can divide it and you will get a whole number. For example, 12 divided by 4 equals 3. So because I can divide it by 4, 4 is a factor of 12. I could also divide it by 3 and get 4, which is another whole number, so 3 is a factor. And I could also have 12 divided by 12, which is 1, 12 divided by 1, which is 12, 12 divided by 6, which is 2, and 12 divided by 2, which is 6. Those are the factors of 12. Now, when we are finding equivalents using common factors, factors that numbers have in common, my 12 and my 10, we need to find a common factor, a factor that they both have. So, if I think about the number 10, what are the factors of 10? Let's have a think. So 10 divided by 10 is 1. 10 divided by 1 is 10. 10 divided by 2 would equal 5. And 10 divided by 5 would equal 2. So, now we've done that and we've thought about the factors of both, let's look for the common factors. Now, every single number in the universe has 1. That will always be a common factor with any other number, any other whole number. Now, the other common factor, if we look, is the number 2. So if I use 2, we're now thinking about dividing to find an equivalent fraction. So this time, I'm going to start with my 12ths, and I'm going to divide it by 2. If I do 12 divided by 2, I get 6. And then because we're working with equivalent fractions, we do the same to the numerator as the denominator. So then, I have to do the same to the numerator of 10. I have to divide that by 2 to get 5. So 5/6 is the same as 10/12. And actually, looking at my fraction wall, if we go along to 1, 2, 3, 4, 5, 6, that's where 5/6 are. And if we go down, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10/12. And if you can see, I'll put my pen there. I don't have a ruler to hand today, but I'll use my pen. They represent the same amount. But this time, we've simplified. We've gone from 10/12 and we've simplified down to 5/6. So, I'm going to have a look at one more with you, and then I'm going to give you a few to think about, and then we'll come back and look at some answers together. So, let's start with, let's try this one to start us off with. Let's try 3/8. Now, let's have a quick think. Now, for this one, we're going to struggle to use common factors because 3 is a prime number, so it will only divide by itself of 1. So for this one, I would think, right, I'm going to use multiples for this. So, let's think about multiples of 8. Or I could do multiples of 3. It doesn't really matter which one I start with, but I usually start with the denominator. Now, 8, let's think about multiples. If I double it, nice and simple, 8 divided by 2 give me a new denominator of 16. Now, because I've done that to the denominator, I do the same to the numerator. 3 multiplied by 2 is 6. So 3/8 and 6/16 are common equivalent, beg your pardon, they are equivalent fractions. Now, I could then go back to my 3/8 and think, right, what else might I do? I might do it further down here. I might make my 8s into 40ths. Now, to get from 8 to 40, I'm going to go all the way around here. This time, I've multiplied that by 5, because 5 multiplied by 8 gives me 40. So if I do the same to my numerator and I multiply by 5, 3 times 5 would give me 15 40ths. So that is another equivalent fraction of 3/8 and of 6/16. They all represent the same amount. So I'm going to write some fractions on here, and I would like you to see if you can have a go at coming up with 2 or 3 equivalent fractions. And if you want to challenge yourself, you might try and see if there's a way of simplifying down using those common factors. So, give you a couple to think about. We're going to try, we'll try 2/6, and we'll also try 3/5. So there you go, there's a couple for you to try. You pause the video now, and then in just a moment, I'll go through some of the possible answers that we might have come up with for these two. Okay, so let's have a look at these. Now, let's think about some factors here. Right, I know that I can divide 6 and I can divide 2 by 2. That's a common factor that they share. So, I'm going to try that one. I'm going to divide both of them by 2. And this way we're simplifying the fraction slightly. 2 divided by 2 is 1, 6 divided by 2 is 3. So 1/3 is an equivalent fraction. It is equal to 2/6. Now, there aren't any other common factors that I can use, so now I'm thinking about multiples. So let's try 6, let's try multiplying by 3. So we'll multiply the numerator and the denominator by 3, and that will give me 4. It won't give me 4. Do excuse me. 2 times 3, 6. And 6 multiplied by 3 is 18. So 6/18 is equivalent to 2/6, which is equivalent to 1/3. Now, if I think about my 6ths again, I could say, right, I multiplied by 3 that time. If I was to multiply by 5, let's try that. Let's multiply by 5, multiply by 5. So 2 multiplied by 5 is 10. 6 multiplied by 5 is 30. 10/30ths. So 1/3, 1/3, 2/6, 6/18, and 10/30ths are all equivalent fractions. And for that one, we could use a common factor to find a third, but we could also find many different equivalents using multiples. This method using multiples can go on and on and on. We can do lots and lots of different ones. So you might have found some different ones to me. Now, 3/5, let's have a look. Now, if I'm thinking about 5 and 3, the only common factor, the only number they can both be divided by is 1. And that doesn't really help us here because it will leave us with the same fraction we started with if we divide by 1. So we're only going to be able to think about multiples. So, let's try, you might have done differently. I'm going to multiply by 4, I think. That's going to be my first one. I'll multiply both of them by 4. So 3 multiplied by 4 is 12. That's my new numerator. 5 multiplied by 4 is 20. That's my new denominator. Now I've got 12/20ths. I could possibly go back to common factors because 12 and 20, I think, share some factors. Let's have a think. So 12, we've got numbers like 12 and 1 are factors. 3, 4, 6 and 2 are all factors of 12. Now if we think about 20, we've got 20 and 1. We've got 2, 5, 4 and 10. So 4 might be a good one. We've used that here already. 2. Let's try 2. So if I was to divide by 2, as long as I do the same to both, 12 divided by 2 is 6, and 20 divided by 2 is 10. So 3/5, 12 20ths, 6 tenths are all equivalent fractions. So there we are. Equivalent fractions. You can use common multiples or common factors, and you can calculate and think about fractions that represent the same amount, that are equivalent. So well done everyone. I'll be back next week to carry on thinking about fractions, and next week we're going to have a little think about adding different fractions and how we would use this skill to help us. Okay, take care, stay safe, and I'll see you soon. Bye.